So today is the second part on solving linear systems by combinations. This should be part 2. And so we're going to do the same thing as we did yesterday. This time, though, what we'll have to do is, in the second step, after we get our equations in order, I'll have to multiply one or both of the equations by a number so that my coefficients of just one of the variables are opposites of each other. And just remember that opposite means that the coefficient is the same number but different sign. So with this first one, again, I want to get my variables to be the same number with a different sign. So I'm going to multiply the top by 2. Oops. And I have to multiply each term by 2. So I get 18x minus 6y equals 20. Then 3x plus 6y stays the same, equaling 2. So then negative 6y and positive 6y cancel each other out. I'm left with 21x equals... Oops, I forgot to multiply. Mr. Metzger making mistakes. Should be 40. There we go. So when I add those together, then I get 42. Divide both sides by 21. So x equals 2. Then just like we did yesterday, plug the 2 in for x of one of the equations. So you get 6 plus 6y equals 2. Subtract 6. 6y is equal to negative 4. Divide by 6, divide by 6. So y is equal to negative 2/3. My ordered pair then is 2, negative 2/3. And again, I'm looking to get these to be the same number, different sign, and so to do that I can find the least common multiple between these numbers. So if, in the same example, if I wanted to get the x's to cancel out, I would multiply the number, the bottom, by a negative 3. So then I would get 9x minus 3y equals 20. And then on the bottom I would have negative 9x minus 18y equals negative 6. I could do the same thing and get the same answer. So again, I'm just looking to try to get those to be the same number with a different sign. This second example is kind of tricky. Because this one was easy, I just had to multiply one of them. In this second example on the right, I'll have to multiply both of the equations. So to get my x's to be the same number with a different sign, the least common multiple of 3 and 4 is 12. So I can multiply the top by 4 and the bottom by 3. So I get 12x plus 20y equals 24. And the bottom is negative 12x plus 6y equals 15. Again, my x's cancel out. I'm left with 26y equals 39. Divide both sides by 26. And so y is equal to 1.5. Plug it back in for y of the second equation I'm going to do because it looks easier. So get negative 4x plus 2 times 1.5 is 3 equals 5. Subtract 3 and divide by negative 4. X is equal to negative 1/2. Write it as an ordered pair. Negative 1/2, 1.5. If I wanted to get the y's to disappear, to cancel each other out, the least common multiple of 5 and 2 is 10. So I'd multiply the top by 2, and the bottom I'd have to multiply by a negative 5. I'd have to do a negative 5 because 5 and 2 are the same sign, and so I need them to be different signs, so I multiply one of them by a negative. So that'll get me 6x plus 10y equals 12. and then positive 20x minus 10y equals negative 25. And I would solve it the same way. Get my y's to cancel out, and roll. This word problem we did two days ago. You had two different equations. You had x plus y equals 525. And then you had 4x plus 6y is equal to 2,876. So for me to solve this by doing combinations, what I can do is I can multiply the equation on the left by negative 4. So I get negative 4x minus 4y is equal to negative 2,100. My x's cancel out. I have 2y is equal to 776. Then I divide both sides by 2 and get y is equal to 388. That would be the adult tickets. And then I plug 388 in for y. And so you have x plus 388 is equal to 525 minus 388 minus 388. So x is equal to 137. And that's how many students. And there you go. There's the homework.